Okay. Presentation related with comparative analysis of quantum technology and classical computing, advantage and drawbacks. With the author is Gabriel Silva Atencio from Latin American University of Science and Technology, ULACIT. Okay. Well, the main topics that related with this presentation will cover rapid evolution of computing paradigms, classical versus quantum, quantum computing leverage superposition and entanglement, classical computing faces limit due to Moore's law, needs to comparative analysis to guide the future integration and hybrid model as promoted pathway. The research question and the objective, the main question related with this research is what are the comparative advantage and drawback of quantum computing versus classical computing? And the main goals are analyzing computational efficiency, scalability, and error rates, evaluate the real-world applicability in AI, security, and optimization. And the last one is propose frameworks for hybrid quantum, classical, and integration. Based on this, the methodology that we're proposing for this research is a qualitative and explorative approach that we have the following variables as part of the research. The metric related with computation speed is that the quantum computing will be between 1.2 and 10.3 microseconds versus classical computer that is 4.4, 5.4 and 40.2 microseconds. The error rate in quantum computing is in the range of 0.2 and 2.3, and classical computing is 0.1 and 5.9. The energy efficiency is higher in quantum computing versus lower in classical computing, and scalability in quantum computing is better with complexity, and classical computing declines with complexity. What are the advantages of quantum computing? Until now, the advantage is speed, because provide exponential gains in optimization cryptography based in short algorithms. Parallelism, because quantum computing uses qubit superposition to enable massive parallelism. Energy efficiency, because quantum computing provides low energy per operation in controlling settings. And the future proof is potential in AI, drug discovery, and security communications. Drawbacks in quantum computing right now are for error sensitivity, because we have right now the coherence, noise, and high error rates. The hardware demands is a cryogenic system, specializing in infrastructure. The integration of complexity, because right now we have a difficult to merge with existing classical systems, and cost and accessibility, because we have right now high upfront investment and a steep learning curve. Classical computing, the strengths and limits. Right now, the strength that we have with classical computing is mature, based on reliability and widely adopted, a strong error correction, stable infrastructure, and cost-effective for everyday tasks. The limits right now is slower for complex problems, because we have problems with factorization and optimization, and the energy consumption high at scale. And the problem that we have right now with Moore's law, because we have something related with protein. Right now, the hybrid model on approach related with is that the idea to use quantum computing is to combine the strengths of both paradigms, that classical versus quantum, and try to provide a hybrid model. Also, quantum right now have a complex to try to run subroutine, classical for control and post-processing model, and the idea to enable gradual adoption and practical deployment. One of the interesting things that we have with this hybrid model approach is that maybe support AI, cybersecurity, use case as a logistic, and HPC integration. What are the ideas or right now the future research for or direction related with this approach? First of all, try to enhance it, the quantum error correction method. The idea is try to, at the moment that we must provide a massive generation or try to scale the quantum models. The idea is that or the adoption of the quantum model in the market, we can provide better ways or better solutions because more researchers, more industry will be adopted the quantum computing to try to test and try and test the solution and try to close or validate the error correction that we have right now. Second, the standardized benchmarking of our hybrid model. The idea that we need to promote the adoption of this to try to generate more use case in the market and try to uh, generate some kind of evidence and test with the industry to try to adopt a quantum computing as part of the one of the elements of the fifth revolutions. Quantum safe and cryptography development. One of the issues that we have right now as part of the quantum computing is that the cybersecurity is emerging very fast and providing right now a lot of vulnerabilities with the current evolution of the technology. With quantum computing, the idea is try to promote and try to give a better or robust architecture to try to protect some companies and industries right now. And scalable quantum hardware for real world use. Until now, one of the issues that we have with quantum is that quantum is running on huge equipment in some labs that if companies wants to access these labs need to access through uh, cloud computing and try to get access remotely for this kind of a benefit related with quantum. The idea is to promote or how to scale this hardware and provide better hardware in a small size and try to provide this or give this to the companies and the industry. And the idea is try to promote and generate more close disciplinary collaboration frameworks worldwide. Okay, several regions need to start to work together and promote the use case to try to impulse this. What is the main conclusion related with this work? Very interesting that quantum computing offer right now transformative potential, but is still not ready yet to try to replace the current traditional computing that we have right now in the market. Of course, right now we are in the transition of the fourth revolution to the fifth revolution. And the idea is that right now we are improving everything related with more speed in communications, more requirements in the capacity for storage, or more capacity or necessity to run process very fast. The idea of this is we need to start to work with this hybrid model and promote with this hybrid model the transition for the traditional computing to the new computing that this is the quantum computing. For this reason, hybrid quantum classical model will represent the most value path forward to try to leverage or try to introduce this model in the new era. And also the urgent need for post-quantum security to improve error connection, scalable infrastructure, and the idea that if we are using a new technology to improve performance, improve a transaction, the idea that this performance, this transaction on this technology will be covered or will be secure at the moment that we use in our markets. And the last one, we need to impulse or promote the continued research and the cross-sector collaboration to try to have essential practical adoption in the market. What are the implications for engineering and in industry? In the case of engineering, the idea is to provide a new tools for simulations, optimization, and AI training. Also, in the case of the industry, enhanced security, supply chain optimization, and financial modeling. And the case of the policy, we need to promote a need for a standard or frameworks ethical guidelines and investment in quantum-ready infrastructure. This is my presentation related with this research article. This is my contact in case that you need additional information. It was a pleasure. Thank you.